Today our topic is prove lines are parallel. So our essential question is, how can I use angle relationships to prove lines are parallel? First off, we have postulate 16, which is our corresponding angles converse. Alright, so remember, converse is the opposite of an if-then statement. It switches your hypothesis and your conclusion. So it's taking our corresponding angles postulate and it's flipping it around. So if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So now, if we know that when two lines being cut by a transversal, so two lines being cut by a transversal, if we know that corresponding angles are congruent, then we can say that the two lines are parallel. We're not told that the lines are parallel. We're told the angles are congruent, and we're proving that the lines are parallel. So if we're proving, we're using the converse of our postulates and theorems from last unit. So same thing follows for theorem 3.4, alternate interior angles converse. So if we know alternate interior angles are congruent, then the lines are parallel. Same for alternate exterior angles and consecutive interior angles converse. So we're using the converse so that we can prove lines are parallel. So example 1 says find the value of x that makes m parallel to n. So we're looking at two lines. We want the value that would make m and n parallel, which would mean that these two angles need to be congruent in order to make m parallel to n. So it would have to be 3x plus 5 needs to be equal to 65, because these would be corresponding angles. So based on our corresponding angles converse, as long as those two are congruent, then the lines will be parallel. So undo plus 5 with minus 5. We have 3x equals 60. Divide both sides by 3. We have x equals 20. So the value would be x equals 20. Can you prove that lines A and B are parallel? Explain why or why not. So if we look at the first example, line A and B are being cut by this transversal. We have our interior, our exterior. We have bottom and top, so opposite, alternate exterior angles. Since we know that our alternate exterior angles are congruent by these markings here, we can use the alternate exterior angles converse to prove that the two lines are parallel. In our second example, let's look at what we're given. We're given our two lines A and B cut by the transversal. We have our interior, our exterior. We're told that the sum of angles 1 and 2 is equal to 180, so they're supplementary. If we look, though, the angles that we're given are alternate interior angles, and in order for the lines to be parallel, it would need to be that these are congruent or that the angles are on the same side, so consecutive interior angles. So no, we cannot prove that those lines are parallel. Example 3. Prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So we're proving the alternate interior angles theorem, or converse, excuse me. So we are given that angle 4 and angle 5 are congruent. So angle 4 and angle 5 are congruent. That is our given. So for reason number 1, given. Number 2, angle 1 and angle 4 are congruent. Why can we say that? Well, if we look at the diagram, we have vertical angles. And we learned a theorem in Unit 2 that dealt with vertical angles, which is our vertical angles congruence theorem, which states that vertical angles are congruent. Angle 1 is congruent to angle 5. We've got that crisscross pattern going on. Two things are congruent to the same thing. Therefore, we can set the other two congruent to each other. That is the transitive property of congruence, which I know you all just love. And we are working with angles, so it would be of congruent angles. And then the last piece, angle 1 is congruent to angle 5. We've now shown that corresponding angles are congruent. So since we shown that corresponding angles are congruent, we can use the corresponding angles converse to state that the two lines are parallel. Please note that if you are proving lines are parallel, you must be using the converse. If you just state the corresponding angles postulate, then you are not proving lines are parallel. That means you've been told the lines are parallel. So we need to make sure we're using the converse and the postulates correctly in the correct case. Example 4. If you use the diagram at the right to prove the alternate exterior angles converse, what given and proof statements would you use? So if we wanted to set up that proof, what would be our given? And what would we want to prove? Well, it's the alternate exterior angles converse. Converse means we want to prove that two lines are parallel. So if we look at the two lines, it'd be J and K. We'd want to prove that J is parallel to K. That would be what we want to prove. What we are given is, if we look in the diagram, we'd be given that angle 1 is congruent to angle 8. It'd be the alternate exterior angles. We are told that they're congruent. We'd want to prove that line J, is parallel to line K. Bonus points to anybody who completes that proof. Give me some steps in the middle. Kind of complete it like you would this proof. Kind of think it through. See if you can come up with a way to prove the alternate exterior angles converse. And no Googling it. Last piece, theorem 3.7, the transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So here in our example, we have P is parallel to Q, and Q is parallel to R, which then means P and R would also be parallel to each other. Transitive property. It works for parallel lines as well. Example 5, each step is parallel to the step immediately above it. The bottom step is parallel to the ground. Explain why the top step is parallel to the ground. Well, if the top step is parallel to the step immediately, the step immediately above it. So if this step is parallel to the step immediately above it, and then the blue step is parallel to the green step, the red step and the green step would be parallel by the transitive property, which can apply to all the steps, so it would just be by the transitive property of parallel lines. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.